Welcome to my little presentation here where I'm going to be talking about a key topic around security, but we're going to be touching on some automation as well. So my name's Nuno. I am a technical marketing manager inside of the Ansible BU at Red Hat. And we're going to be looking at a very specific use case where, Ansible actually has a really strong story, and that is zero trust. So for us to understand about zero trust, we're going to talk a little bit about it, some of the key aspects of it, and then we'll have a look at how Ansible can actually fit into this. So in general, from a zero trust perspective, this is part of Red Hat's mission statement that basically, we really believe in the concept of zero trust. And, the principle of never trust, always verify is really, built into our systems. And, whenever we're talking to our customers or our partners, this is something that we always in trying to design for, right? And we're always trying to advise because it is obviously a better way. It is a secure way. So just in global, from a whole portfolio's perspective, this is something that's really important. Now, from a zero trust perspective, let's dive down a little bit. So let's understand this because zero trust architecture is quite complicated. There's a lot of moving parts. And if you're not, in there, getting your hands dirty, sometimes it can be a little bit abstract. So I think the best thing is to actually dive back and look at some of the fundamentals and go through these. So what necessarily is, zero trust? What is it all about? Well, from a security standpoint, we used to have a very old model where the concept basically was, the bad guys are outside and anything inside seems to be okay, right? So we can trust, the systems and the people, etc., that, are on our internal network. Now, this is obviously problematic because, once you've breached that environment, you have nothing stopping you from just going wild and basically making lateral moves and breaking things, finding things, etc., whatever your typical, bad actor would do. So this is where the concept of zero trust comes from. And this is basically, whether you're a person or a system or an application, you must consistently prove yourself in this environment. So this is where that whole, never trust, always verify statement comes in. So effectively, yes, we need to have some kind of identity management that we can reference. But all along, the path of working with our infrastructure and our systems, we need to have a way to verify, the person that wants to do something or the system that wants to do something is actually allowed to do something. So we don't even consider, the inside outside because we have this stance, which we'll touch on a little bit, where, we assume that the system is in breach at all times. Now, some of the core principles around zero trust architecture, we've got some of them here, and we'll dive into these from an Ansible perspective. But like I said, never trust, always verify. So again, every single request we need to verify. We want to have least privilege. So you will get the permissions based on what you really need to do. So the lowest privilege, nothing more, nothing less, and this maintains a least privilege stance. We assume breach at all times. So what does this mean? This means that we don't design to keep people out. We just assume that someone has already gotten in. So therefore, we build the systems around that. So should someone already be in the network, what would we do to try limit them, to try limit their impact? And, build the architecture and the steps all around that. Deny by default, obviously, we want to be able to make sure that that's kind of the norm. Deny before anything else, and if we have to modify that, we can remove that default. Now, some of these other components are, a little bit abstract in the sense of things like microsegmentation. Microsegmentation talks to the network specifically, and this is all about, breaking the network up into smaller pieces, which are then more manageable, more secure. And, obviously it doesn't mean that, you jump onto the main VLAN of an environment, you now have access to systems and to cores, et cetera. So we want to ensure microsegmentation, in our infrastructure. Now it goes without saying, obviously things like continuous monitoring. We want to be able to monitor and see everything that is taking place. And this is actually really cool for us from an Ansible perspective because we do have a component called event-driven Ansible, which is really good at listening to, these observation platforms and basically allowing us to automate responses based on what's taking place. And we'll have a look at that a little bit later. Things like identity-driven access. Yes, we need to have some kind of central identity store where, we can control who we are, what are the aspects of that person, which groups they belong to, etc. So normally this becomes a central point in terms of what we're going to do. And then lastly, workload identity. A lot of this that, we're talking about in terms of core principles is all about, I can log in and I can do X, Y, and Z. But what about systems changing systems? And this is where workload identity is actually really important. So we'll have an example of this and I'll discuss this, when we get there. Okay, so now let's touch on why we want to use Ansible specifically, why the Ansible platform for zero trust architecture in an organization and what the benefits, potentially could be. Now, before we dive into that, this is more than just, integrating Ansible into zero trust or integrating that into your zero trust environment. And we'll dive a little bit into that in terms of why. But just on the, in general, when we're talking about automation and we talk about Ansible specifically, sometimes we don't necessarily talk about, what the use cases or implications could be of Ansible for security. So just off the bat, we do have some really straightforward use cases which can be deployed straight away, once you have a platform in place. Things like compliance. I mean, compliance is obviously very important and hardening is very important. So regardless of what you're doing, perhaps you're a customer that requires a certain level of compliance or compliance framework like STIG or, CIS or anything like that. This is actually really straightforward from an Ansible perspective. And the fact that Ansible is able to, talk to multiple domains, technology domains, this can really become quite a beneficial use case for us. The fact that we can automate the network, the hosts, the hypervisors, driving compliance and hardening is pretty straightforward for us. Outside of that, things like identity and access management, obviously from a platform perspective, we have, role-based access, etc. But being able to automate these tasks, password resets, maybe binding systems to LDAPs, etc. This is pretty straightforward for us. System hardening, I mentioned that from a compliance perspective, being able to roll out hardening at scale across whatever platform you have. This is pretty powerful in terms of responses, right? So even if you're not following some kind of compliance criteria, you can still go through a stock standard hardening process for your infrastructure. And with Ansible, you could obviously schedule it and make sure that that is always kept up to date. Now, things like policy enforcement, we're going to show, and you're going to be able to see that in terms of where it fits in with Ansible. But one thing I do want to point out is obviously things like event monitoring. Like I said, we do have event-driven Ansible now as part of this platform, which means we can go and we can pull information out of event sources. And from those event sources, that could drive the adoption or the automation that you want to roll out. So whether it's a firewall incident and you want to go and trigger some kind of response, or if it's just, fact gathering, you just want Ansible to go get a bunch of information from the system because, there was an event that came through Splunk. That's all fairly easy, fairly straightforward with Ansible, and a pretty common use case from Ansible usage. Okay, so now this is now where we start getting a little bit interesting from an Ansible perspective. So in Zero Trust, you have certain components that you need. So we often talk about things like a decision point, right? So the decision point would be typically a policy server. So this would tell you, what someone can do, what they're allowed to do, and then obviously the denying component of that as well. So decision point is in there. We also then have an information point. So all these components that provide us some kind of context. So whether it's an identity management system, SIEM, or something like Splunk, for example, these are all providing us components for information. Now, instead of just taking Ansible and integrating it into all of this is where Ansible can be quite powerful from Zero Trust. Because Ansible could be a policy enforcement point. And what do I mean by that? I mean that Ansible could become a central component where, if I need to go and make a change on an environment, I can go and drive it through automation. And part of that automation is to be able to make sure that all the checks and balances are in place. So being able to check the policies before we apply any changes, et cetera, et cetera. So this is what we will kind of focus on. All right. So Ansible itself, why does it, fit that policy enforcement point? Basically, it's a single platform, firstly, that uses the strengths of Ansible in terms of being able to automate multi-domains. So you now have a really flexible tool that you could enforce those policies depending wherever you are, if you're doing infrastructure or if you're doing cloud or if you're doing a network. We have policy as code, which is built in. So we have a way of actually gating what we're trying to do and check with policy servers to make sure that before we automate, this person's allowed to do that, right? We also have a way to not keep credentials. Now, this is really important because obviously the platform has a credential database and you can keep your credentials there. But ideally, from a zero-trust perspective, what do you want to do? You want to be able to integrate that into something like HashiCorp Vault, and basically just query the vault for credentials and have those credentials injected at runtime. So we don't actually have credentials or any type of sensitive information going into the portal. Outside of that, obviously, we can plug into things like IDM, we can plug into LDAP, to be able to gather identity. We have event-driven, which is obviously assist us from a monitoring perspective. And we also have a full audit trail. So if someone were to go and run a job or some kind of automation, you can actually always go and look and say, okay, who ran the job? What were the results of the job? You could always have this full policy-backed audit trail that you would always look back on, right? So all these key aspects really enforce the Ansible automation platform as a policy enforcement point. So it's not only about that, right? Obviously, we have other technologies around. So zero trust itself, it does require what we call a full stack approach. So this means that, okay, we know that Ansible has got all these really cool features and it kind of fits within that policy enforcement point. But what about everything else? Well, from an application layer or application workload, we're able to, trigger APIs. We're able to use the item.z from Ansible to drive certain changes. So we have the ability to do that from an application side. From the lower side of things, where we're actually talking about the hardening of the infrastructure itself, again, this is where Ansible steps in really well because we can ensure the compliance and the hardening of our platform. So based on things like STIG, we can ensure that that infrastructure is STIG compliant. It's already been hardened, and in terms of playbooks itself, things are isolated, SE Linux isolated. So we're able to keep that low stack isolated as well, right, from an infrastructure perspective. Now, from Ansible, we always talk about, like we said, multi-domain. What do I necessarily mean about that? Well, it means that Ansible can generally automate most components. So we can automate things on infrastructure. We can automate network. We can automate public cloud, edge use cases, private cloud, and even things like ITSM. So if you think about a bigger situation with Ansible, one type of automation could include all of these. Perhaps you are deploying infrastructure in the cloud. You then want to run compliance on top of that infrastructure. You want to make sure the network changes are there. You want to make sure the firewall changes are there. And you want to gather all this information and put it into some kind of ticketing system. Ansible is the one platform that will be able to tie all of this in and orchestrate all of this automation. Right? So this is why it's a really strong tool for what we call foundational security. Okay, so let's now dive into some of these use cases. I'm going to use some of these examples on how Ansible is acting as a policy enforcement point, and where the strengths are really on how all of this works. And then I'll show you one of these use cases. Okay, so now we're going to say we wanted to deploy an application. So where can Ansible, what would Ansible typically use to deploy this application in a zero trust architecture, in a zero trust way? Well, ideally what would happen is, obviously we have IDM or we have some kind of accounts. The person or the user would log in with these accounts and they would trigger this kind of deployment. Now, the first thing that Ansible would be able to do is we'd be able to do a check policy, right? So part of this automation workflow, the first step would be to check with policy servers to make sure that the specific user is allowed to actually run this job. Now, should that job fail because they are out of policy, then what would happen is you would obviously get some kind of indication to say this user is not authorized, and therefore the policy is enforced that no changes can take place. Now, if that person is actually able to do that, this is where we start to drive this specific example a little bit further. So once we've proven our identity and the policy has been passed, then basically the job is allowed to run. And this example is a workflow. So for those of you who are not familiar, Ansible allows us to build up these logical workflows step by step, and we can automate step by step, tie them all together to get a bigger orchestration of end-to-end automation at the end. So the next step from here would be to create short-lived credentials. So from this perspective, Ansible will then be able to talk to a tool like HashiVault and request randomized short-lived credentials of, let's say, 5 minutes. So what would that do? Well, now HashiVault can present us this randomized password and inject it back into Ansible's run, right? And we will then use that as a variable to configure the database. So the database that is basically the backend for this application that we're deploying now will be given a credential that it could use that would rotate, right? And we would obviously have some kind of automation to then maintain this rotation. You could use something like a schedule where we query the credential, update the database, update the application, and keep rotating. But effectively, you've now created this database that's based on a short-lived credential. Next, we have to configure the network, right? So I'll show you this in the demo in terms of the breakdown, but effectively, think of a network where we have a data plane and we have like an application plane where we have our application servers. We want to enforce microsegmentation. So at this point, what would Ansible do? Ansible would go and create, the segmentation for these two networks and make sure that we have things like access lists in place and any further network policy to allow that specific application server to talk to this database. And then lastly, what we're going to do is the application itself would then be updated as it gets deployed with the database details as well as the short-lived credential. So now you have a situation where Ansible's acted as a policy enforcement point because it's gone firstly and checked, can I actually deploy this? And if I can, we're now going to go through and hit a few aspects of the zero trust. We're going to be using short-lived credential, for example. We're going to use microsegmentation and network policy to enforce those policies on the network. And then lastly, deploy the application and connect everything. So now your application will be live. And, if you had a short-lived credential for 5 minutes, as soon as that 5 minutes has expired, that credential becomes invalid. And typically your application would disconnect from the database. So that's where you would rotate that. So this is a really straightforward example of where we're using zero trust principles, and Ansible is triggering all of these steps in one go in a workflow. Now, policy as code, which is what I mentioned beforehand, is a way that we can check the policies, and it's actually built into the platform itself. So when we run an automation play, the first thing it does before it actually triggers the automation is it queries with the policy server to say, is this execution actually allowed or not allowed? If it's not compliant, then, the job will not ever run. Whereas if it is compliant, then obviously the job is triggered and, we carry on to the next steps. Now, this is what we call an outer ring or a gated response that is built on the platform. And we're going to see how we can actually use this to drive a further more enriched kind of use case around zero trust. So this is where we get to what we call zero trust layers, right? So zero trust needs layers. It can't just, we have to always remember this never trust, always verify kind of statement. So this is an example. This is kind of like a two-ring enforcement here where we have our outer ring, which is a policy as code, which we just saw. So when I log into the platform and I run a job, it will first check, am I allowed to actually run this job? Or whatever type of policy we check in. And if it's successful, then obviously it will trigger the job and we'll carry on. If not successful, then it will deny it when we start. But to add layers means, okay, well, we have that right at the beginning that's provided by the platform. What if I have to go and actually check for policies internally while I'm running the automation? So this is what we call the inner ring. And this is typically where we could have these types of policy checks inside the templates or the playbooks or inside of an actual automation workflow. So every time you would have to go ahead and make some kind of change, you can actually query policy and see if that change is allowed. And if it is allowed, then obviously continue to the next step. So this is a multi-layered approach to doing automation and to do changes. And you can see probably the value of this. If I had to go and make a network change, I might be part of the network team, but maybe I'm not at the right level to make this type of change on a certain set of switches. So if we have this layered kind of policy checks during the automation run, that secures what we're trying to do even more. Okay, so here's an example. This is a multi-layered an example of policy as code and policy enforcement with some workload validation. So I now have to go and run a change. I need to go and deploy a change, and I would run this change for, let's say, adding a VLAN, which will be our example. Now, if I run this and I'm not part of the network team, more than likely the policy as code would be our first step, and it would be denied. I'm not part of the right network team. I shouldn't be allowed to make network changes. So our outer ring protects us and kills the job, and now we sit in the denied state. But maybe I am a network engineer, and now I log into the platform, or I trigger execution on the platform. Again, we go through the policy check from policy as code, but then we actually trigger the proper automation workflow, and this is where we would start adding our multi-layered checks. So we would say, cool, I'm allowed to run this, so now this deployed VLAN change is going to take place. The next step is another policy check where it says, okay, so this user is part of the networking group, so they're allowed to run that. We've gone through the outer ring. But, what is the time that they're running this? Because we typically only allow network changes between, 3 and 4 in the morning on the Thursday. Or perhaps we want to change a VLAN, and maybe the VLAN ID can only be a certain range. These are all the things that we could kind of put into a policy for a policy check. And effectively, maybe I am the right user, but maybe the time of day is wrong. So if I'm trying to make a change on Friday, this could be an automatic deny there. So I am the right person, but inside of the inner ring enforcement, it's the wrong time, therefore it gets denied. All right. But now let's say all the pieces are correct. I log in as a core network admin, and I'm going to make these changes, and I run the deploy VLAN change. Obviously, outer ring, I'm in the right team, not a problem. We go into the inner ring. We have the secondary policy check. I'm on the right user, I'm in the right groups, it's the right time, it's a valid ID. But I'm trying to make changes to the core switches. Now, the next step is, okay, well, we can use workload validation here. And this is where things like Spiffy Spire come in. So those of you who might not be familiar with Spiffy Spire, basically it allows us to create a ID which then needs to get verified. So what happens in the automation space is once we've gone through the first sets of policies, it will then go and query for a Spiffy Spire ID, which we would then verify. So perhaps my automation platform there is trying to make changes to a core switch. But if we're not allowed to make those changes, and we actually have a policy that says no automation can actually take place in the core switches, this needs to be human engineer only, this is where a policy check with workload identification would be really helpful. So what happens is our templates go and we query Spiffy Spire, we go through the Spire server and we query the ID, and an ID returns. And then that ID gets checked against policy again. So we will have a policy that says, look, this automation controller's ID is not valid to make changes on core infrastructure or on core switches. So then at that point, the job gets denied because it's an invalid Spiffy ID. Okay. So you can see that we've built up multiple checks, not only user-based checks at runtime. We've dived deeper in terms of what is this user trying to do. So looking at the VLAN IDs, for example, to make sure they're correct. Or even diving into what time, maybe this change is only allowed at midnight. We have the ability to do that. And because we're adding that into either the playbooks themselves or into the workflows, we can consistently verify what needs to take place to follow the zero trust model. Ultimately, if we go through all of this and we've now passed the Spiffy Spire test, which is checking our actual workload identity and not necessarily the user identity, the automation can then take place where we can go and now configure that VLAN with Ansible and then ultimately, update the CMDB with, the details that we now have a new VLAN that's available. So this is how we could use, policy checks inside of our execution as well as before the execution to give us a multi-layered zero trust architecture with Ansible. Now, this is quite a nice example as well, which is touching on defense in depth, right? So this is all about some kind of hardening failure, where ideally what we want is we want to have multiple layers when we harden systems. We don't just want to rely on one. So with Ansible, we would able to do this. We'd be able to go and drive things like firewall changes to ensure that source IPs are restricted. We want to be able to uh, ensure things like IDM-based, host-based access, so that, for example, you can only SSH into systems with you have an account that's on our identity management server and you within the right grouping, etc. And then we can also enforce things like short-lived certificates. So think of, instead of using SSH keys, you could rely on certificates which get rotated by a hashy, um, and then put all those together so that we can ensure that we can log into systems. So this is the way that we can really harden our infrastructure with this outside of, things like compliance profiles. And here we start to see an example of where we could use things like event-driven. So I can have Ansible that triggers all of this and make sure that our infrastructure is maintained with these specific layers to harden. And now we have an example where perhaps someone is trying to actually hack into these systems. This information is already being sent to a central source. It could be sent to a SIEM, it could be sent to something like Splunk. Here I've got an example of Splunk because it integrates really nicely with event-driven. And once this, KPI comes through from Splunk, because maybe perhaps there's some kind of attack here, and we have a trigger for this in Splunk. Splunk will then go and query event-driven and send it a payload in a webhook. And event-driven will actually filter for this payload, and based on the conditions that we create, then ultimately we'll go and trigger some kind of action from Ansible. And a lot of the times we talk about things like self-healing, etc., but this can be really valuable just for information gathering. Someone is trying to break into your systems or trying to, access things with like SSH keys, etc., etc. All this information can be handed off to Ansible and trigger some kind of action, even if it's just a case of, okay, we'll connect to the systems that are being affected and start auditing those systems, start getting some information, maybe talk to the network stack to see what's happening, where's this traffic coming from, create service ticket and put all this information in there. Or you can go straight forward and just say, okay, well, we're going to gather the IP address that's coming. We're going to talk to the firewall. We're going to go and block that IP if you want. We're going to, maybe reroute that traffic to a honeypot to see, maybe our security team wants to see what this attacker is trying to do. There's so many things, but it can all be automated because event-driven is aware of this coming from your information layer, your Splunk, your SIEM, etc. So this is a really cool example. Might not necessarily fix things, but in terms of supporting the security posture, it's quite powerful. And then lastly, something like brute force. So we have the example where, we just saw now where we're getting attacked, and this is an actual thing that we could do, right? So from a zero trust perspective, we have these credentials which have been created and they're short-lived and they get handed out between application and database. But now what happens if someone tries to do a brute force attempt on that application? Well, again, Splunk would be aware of this, or the SIEM would be aware of this because they would see things like, unauthorized password attempt or attempt to log into certain accounts, and they would see it consistently. And obviously you would build out some kind of API to say, hey, we've got 10 of these requests within 5 seconds. I want you to have a KPI around that could send some kind of alert trigger. That alert trigger, once it gets to event-driven, now drives the action in terms of what you would typically do for something like zero trust. So in this example, someone's trying to brute force into our application. We get that information from Splunk. It goes to event-driven. And then ultimately, event-driven would then trigger a bunch of automation inside of a workflow to have multiple steps. So it could be a case of, okay, well then the first thing we need to do is let's remove that application server from our load balancer so it doesn't become part of our stack. And then we want to go and revoke the current credentials that are in place. So we would go and revoke the credentials from a Hashy Vault perspective and revoke them from the database. So immediately what would happen is your application would disconnect from the database. This could also be a verified step. So you could build a playbook that actually verifies what error code you're getting from the application to ensure that, you have revoked correctly. And then we can go and add, additional use cases onto this response, which could be things like updating firewalls, opening up service tickets to provide, the step-by-step run that you've just done. and give that all through to your security team so they can actually understand, what took place at this specific time. And what's really cool is the fact that, we're talking about all these steps taking place, but this could all be taking place at 3 in the morning when, your teams are asleep and no one's actually there to defend your infrastructure. Ansible can kind of fill that gap by allowing you to make tasks or do tasks based on events that are coming through, and then provide your teams that information. So when they come to the office the next morning, they'll see that their application server has been disconnected, and then at the same time they'll have a ticket with all the relevant information that this brute force took place at this time. Here's the indexes from Splunk. Here's the episode IDs from Splunk, and this is what we did. These are all the steps. So this is a really cool use case to show some kind of almost like a threat management from an Ansible perspective, which doesn't really need much, human intervention at the time. Okay, so now I'm going to dive into a little bit of a demo, to show one of these examples off. So we have a platform running. So I'm going to be logging into my platform here. And let me show you just the topology right now. So this is kind of the topology of this environment. We have our AAP controller. We've got a Hashi Vault running. We've got Netbox running to act as a CMDB for information purposes. We have IDM. We have Focus servers. We've got Keycloak. We've got all these things. The only thing that's offline right now is Marvel's RC. And that's fine because we have Splunk acting in kind of that use case, right? Then we have a network, so we've got spine, and then we have two leaf switches. One is a data plane, one is an application plane. And then ultimately we've got a database container and application container. So that's a live environment that's running. So if we go to this, we can see our platform here. We can see, for example, right here, even our rulebook. We have an event-driven rulebook running, which is actually listening to Splunk. So for those use cases like the breach, etc., I could be listening to those types of events. But yeah, otherwise, a few things to touch on. If I go and have a look at my settings, I'm querying a policy server, so I have access to OPA. And this is going to be sending requests before we run the template, right? So this is going to be policy as code from a controller side, which is typically our outer ring. And then we have, in terms of authentication methods, we have an LDAP. So we're tied to an LDAP. We have all the mapping, right? So we've mapped certain teams with certain roles on our platform. So yeah, we have all of this these foundational components. You can see here we have an identity management system, so Red Hat's IDM. This is the backend identity system that we're going to be using for this example, right? So you can see all the hosts running, our users, etc., etc. And we'll have a look at this during this example. Okay, so let's go and dive into our templates. So you can see that I've got a bunch of templates, and obviously we have role-based access. Currently, I'm logged in as admin. So let's go and log out. I want to log in as another user. So I'm going to log in as an app dev. So I'm application developer. I want to go run some kind of automation. So I log in, and this is what I see. I can see the templates that I have access to. You can see I don't have access to event-driven. I don't have permissions to see what's going on there. And I have fairly limited access to some of these other components. So I'm going to go have a look at the templates. I have an application that's been deployed, and I want to go and change the VLAN. So I'm going to run this VLAN template. And I'm quite happy with the VLAN IDs. I'm not going to change anything. And we're just going to submit this job. So as an app user, an app dev, I'm going to now try run and change because I need to go and make changes to the network because, I need VLAN 200 for this specific use case. And now I can see that my job is not executed, and I've basically got a violation. So it says here, the job cannot be executed due to policy violation. And the violation is app user is not in the authorized team for network templates. Okay. It says I need infrastructure or application, and I have application. So this is a policy as code example where before we even run the job, it queries a policy server and it says, okay, this user is not actually in the right team, and therefore we'll cancel. And the job doesn't even get started. We just get this kind of error. So From this example, we were immediately blocked by the outer ring. Cool. So let's go try someone else. Okay, so I'm going to try log in as a engineer, right? So now I'll log in as a network engineer, a network engineering account. And you can see I don't have anything. So I've got no access to anything. I'm logging in through the LDAP, and I obviously have a LDAP mapping that allows organization members to log in, but I might not necessarily have the rights for anything. So let me log out, and then we can see if we can fix it. So if I go from that perspective back into my identity management tool, I can say, okay, well, let's look for our network engineer. I can see there's the account. Let's have a look at his groups. Now, I remember the policy when it failed, it said it needs infrastructure users. So let's add this user to infrastructure. Okay, so we've added that guy to infrastructure. Okay, now let's go try log in and see if we can actually see things now. Okay, so there we go. I can already start to see components now. I can see the hosts. I can see a project that I'm assigned to. I can see inventory. So let's go run that job that we saw, because I should have it now because I'm part of the infrastructure team. So I would run that one. I still need 200. I need it on the DMZ, no issues. Let's trigger this job. So now we're going to trigger the job. Remember, the first thing is we're obviously going to do an OPA check. So right now, that's what will happen. It would do a policy check. It would query with OPA, can I run this template? And if it allows me to do it, then great. Then it allows me to run it. So now I can see that the job has run, but I also have a failure. So let me have a look. So we've checked from OPA, that's the outer ring, no problem. And we can see the failure here is this one. So here, if I look at it, it says VLAN config denied by policy, denied user, neteng is not part of the network admins group. Okay, so now we've enforced a secondary policy and we've lowered down basically who's allowed to do what. So yeah, my network engineer clearly can't make changes to this, can't make VLAN changes at all. So we're going to have to choose someone else. So let's log out. And it said that the network admins are the only ones who can make these changes. So let's work as a network admin. I'll log in. Okay, so I'm logging in as a network admin. And I've already got access to projects, etc. I can see everything is good. So now let's go back into our templates. VLAN. All right, so let's trigger this guy. VLAN 200, DMZ, just like we wanted. And I'm going to trigger it. And again, we're going through the same steps, right? So first thing that's happening now is it queries with the OPA server via policy as code. And it's checking, is this user allowed to execute this job? Should that pass, then we run into the actual template where we now do multiple checks with OPA. So we can have a look here. All right, so we can see here the OPA policy check, which is green. So it says here network admin, groups that I'm in. I can create a VLAN. This has been allowed, right? And workload validation has taken place. So that's talking about spiffy. So let's have a look here. Policy from OPA. All right, I'm allowed to make these changes. So the second policy check worked. And then we can also check for the workload. So you can see here, I've got a task that validates the workload. What does it do? It checks the spiffy ID. So in this step, we've gone and we've shown the certs and we've compared the certs that get issued via the Spire server. And from there, we push that into another policy check because we've got 3 policy checks. And that policy check would then say, okay, this hardware or this executioner that we're trying to run this job off, it has a spiffy ID of X. In the policy, are these IDs allowed to actually interact with this hardware, right? i.e. the switches. So that's where we see this, where it's a validation, right? So it says, okay, this SPIFFE ID under the SPIFFE policy of network automation, under the policy of that, is allowed to actually enforce changes on the network switch. So once all of those checks have been done, then you can actually see the changes taking place. So you can see here the VLAN changes have taken place, and we've added the VLAN to all three switches in this environment. And we've gone the extra step, which is we've actually configured, or we pushed this back to CMDB. So if we have a look here, the CMDB details, we've just injected VLAN configuration has been complete. Here's the VLAN ID. These are the switches. It's been created. It was created by this person. And this is the workload identification that we've used to make sure this takes place. So now your CMDB has all this information central to it. And if someone is monitoring the network, etc., they can see all these changes taking place because Ansible is now put in that. This could have been a service ticket, right? This could have been a service ticket that gets created in service now with this information, and your network and your security engineers would then be aware of what's taken place. But ultimately, when it comes to things like auditing, this information is always there. So you can always go and see who ran what job. And ultimately, you could always go back to the jobs and say, okay, well, what actually took place? And the way that Ansible is structured is you have the step-by-step logic as well as the tasks in terms of what's been applied, what's been changed, etc. So this is a really strong use case around also adding some kind of audit trail from the environment. Okay, so that was multi-layered policy enforcement while trying to do something like a VLAN change. All right, so let's go back here, and we're going to close off now. But I think the key thing here is the fact that foundational security with Ansible is really straightforward. Being able to use Ansible just for things like compliance, enforcement, and hardening is a really easy, straightforward use case to get into. But also using Ansible to gather information and maybe build, kind of dynamic reports is also quite useful. And we typically use this with compliance. But Ansible itself fits really well into the policy enforcement point, which is something that Zero Trust uses and enforces quite heavily. So just think about the state that you could use Ansible to do all of these changes. If I was going to make a change on a environment as a security engineer, or maybe just an ops person has to then make a change for security, the fact that I have to log into a system, do all of these things, whereas I could actually just have Ansible do it, automate it, and while it's doing it, do policy checks, etc., and give us an audit trail in terms of what's been changed. Also, don't forget, a template or a playbook that we build with Ansible. A lot of the times, the best thing to do is take the knowledge that the subject matter experts have and codify that knowledge, so that we make sure that when we're applying changes or we're deploying changes, it's deployed the best possible way that our teams would want to deploy it, right? So this is another thing, being able to codify that knowledge and making sure that every time you run these changes, you're asking for policies, you're always verifying what you need to do, but at the same time, you're making those changes the most correct way that you would have in terms of your organization. Now, outside of that, we haven't spoken about things like certified content, but obviously Red Hat and Ansible has many, many security partners, and they provide us with certified content. So this is modules, roles, etc., which you can use and have backing and support from the partners themselves. So yeah, being able to use Ansible to make these changes within a zero trust environment to be that policy enforcement point really removes additional human error that you might have, and enhances all the consistency in terms of automating at scale and making changes at scale. So yeah, this is basically where the power lies with Ansible. Okay, so thank you for joining. We have many, many resources that you can dive into, and obviously view these types of things in these demos. Thanks.